In part 1, we saw how transformers understand language using attention instead of reading word by word. Now, let's go deeper and understand how they actually work inside. At the core of transformer is something called self-attention, and it works using three components: query, key, and value, also known as Q, K, and V. You can think of this like a smart search system. Every word in the system asks a question using its query, checks all the other words using their keys, and then collects useful information using their values. The more relevant the match between a query and key, the more attention that word gets. This is how the model decides which words are important to understand the context. But before this happens, the model does not even see the words. It sees numbers. And this step is called tokenization and embedding. Each word is broken down into smaller units called token, and each token is then converted into a vector, which is basically a list of numbers representing its meaning. And remember, these embeddings are what the model actually processes. Now, since transformers process everything at once, they don't naturally understand the word order. So we add something called positional encoding, which tells the model where every word is located in a sentence. And this is absolutely important because the position of words can completely change the meaning of a sentence, right? And once we have embeddings and positional information in place, the model generates query, key, and values by multiplying these embeddings with the learned weight matrices. And then comes the most important step: computing attention. Each word compares its query with all the other keys to calculate similarity scores. These scores are then converted into attention weights, which decide how much focus to give to each word. Then all the value vectors are combined based on these weights to create a new context-aware representation of each word. In simple words, every word now understands its meaning based on the entire sentence. But the transformer does not stop at just one attention layer. They use something called multi-head attention. This means that the model looks at a sentence from a multiple perspective at the same time. One head might focus on grammar, one on meaning, and another on the relationships between the distant words. All these insights are combined to give a richer understanding. To make sure that the model does not lose the original meaning while adding context, it uses residual connection and layer normalization. And finally, when the model has fully understood the context, it generates output. In language models like ChatGPT, this means predicting the next word by assigning probabilities to each word and selecting the most likely one. And this process repeats to generate the complete sentence. And that is how transformers work under the hood, by combining attention, parallel processing, deep learning to understand the language in a way which is fast, scalable, and incredibly powerful. If you found this useful, stay tuned.